Hello everybody. Welcome to our third meetup. I'm very happy to see all of you. Some familiar faces who have come again. Very nice. So we'll get started. If you want Wi-Fi access, there is information over there on the board. And if you have to go to restroom, you will go out that door and turn right and you will see a restroom sign over there. So we have two great talks today. Our first talk is on securing containerized applications. That is by Kashif Zaidi. And he is a senior solutions architect at Aqua. And he has been educating organizations on the importance of container security, which I know is of a very popular topic in this group. So let's welcome Kashif.
Great, thank you. Can you guys hear me?
Yes. Yep.
Awesome. Yeah, as mentioned, my name is Kashif Zaidi. I'm with Aqua Securities. So I've been there for about a year now. Aqua Security is a small company based out of Israel. We have about 100 employees now. And what we do is we provide full lifecycle security for containers. Because I work for Aqua, I get to use their tools and show you a demo of how to secure containers. I'm going to try and make this as generic as possible because it's not a marketing, it's really learning. So forgive me if I show you Aqua's logo all over the place. I try to edit it and make it as generic as possible. By show of hands, does anyone know when containers really started? What's that? When did containers really start? 2008? You have your hand?
The earlier could really use like the phone thing.
2000, okay. One more? Guess? Back then.
Solaris?
Solaris was good, yeah. That's back in the 80s probably?
Yeah.
Well, it really started earlier than that. The containers came in when can I get the microphone with the hand?
Yes.
This is really falling off.
Falling off.
Hello? Okay, perfect, thank you. So it really started back in the 70s, really. 79 was when Unix version V7 was out, and that really started to get into containerizing the application. Before that, you had timeshare. What happened with timeshare was when two people logged into the same machine, you could access and you could see what everyone else was doing. You could see their files, you could see what they were doing. So then system admins realized we need a way to isolate it. And it really started in 79. And I won't go through the whole list, it's pretty long. But Docker didn't come into 2013. Like someone mentioned Solaris, that's in 2004. Before that, we had FreeBSD jailed in 2000. And there were a couple more before that in the 80s, the 90s as well. I just didn't put it up, it's just too much to put in. But Docker came out at the right time when you started having AWS cloud services. And everyone started moving to the cloud. And resources were expensive and they wanted a way to maximize it. So Docker came out and pretty much standardized on how to do containers. So I was asked just to give a brief introduction to containers. What are containers? Why they're important? So the benefits of containers are really, they come up in seconds, right? They're really fast. You don't have the whole bulk overhead. It's meant for microservices. It's for agile development. When you need to develop something quickly, you can build it into a container because you don't have to worry about everything else. Everything is within the container. You can really, when you build an image from a container is based off of the image. So they're two separate things. When you build that image, that image could be deployed thousands of times and become containers based on the same image. So it's very, you can scale really rapidly. Also, the whole idea behind Docker is build once, run everywhere. That's Docker's motto. Meaning once you build it, you can take it to any other machine that has a Docker runtime, and it will run without a problem. Well, it should run without a problem. And also, now on this slide is really accountability. There's no one can point to anywhere, oh, that's operations fault, or that's the environment is wrong, or the library in the environment is wrong. Just because Docker is all self-contained, it has everything in it. So no one can point fingers at anyone else anymore. A lot of people ask me, what is the difference between a VM and a container? Here's a good example, a more technical example of how you have a hypervisor environment. You have the server, the host, the hypervisor, the operating system, the libraries, and the application. If you need another copy of the application, you have to get this whole thing up and running again. And same thing on another version of that application. But with containers, you don't have that layer, I guess, OS here. You have the server, the host OS, and then you have the application running on top of a Docker engine that accesses the baseline operating system. So from this picture, you can see it's much nicer, much more efficient. A container environment could run a lot more applications than a regular VM could. Any questions so far on this?
And this also is could be anything. Doesn't need to be only Linux.
It could be a Windows host, yes, correct, right. Okay, and another good analogy that I heard, not from me, but from I heard at DockerCon. Think of a VM as a house. When you have your own house, you have your own driveway, you have your own heating, cooling, you have your own playground, your garage. Everything is all individual for that house. If you need to expand or you need to get another person needs to move in, then they'll build the whole infrastructure from ground up for that house. A container is most like an apartment building, where the apartment building shares the resources of everything underneath. The plumbing, the heating, the parking, the playground, whatever, elevators, the hallways, they're all shared. And then you have apartments, which are more like containers that are, for individual purposes. It's isolated. You don't know what your neighbor is doing. You do what you do, and that's what containers are. I kind of like that one. By show of hands, how many people are familiar with containers already? Not quite a bit. Okay, cool. Just so that I don't leave anyone behind, I wanted to make sure I give everyone somewhat of a background on what containers are. How is an image built? Image is really built from a Docker file. These are the components of a Docker file, really. You're getting the from. The from is probably the most important. That's telling you what the base foundation is. And then you build on top of that foundation with all the other commands. So it's not too complicated once you play with it a little bit. So now let's go talk a little bit more about security. That's the purpose of me being here. So when people think about containers, they automatically think it's secure. That hey, because I'm containerized, I'm in my own individual area, I'm going to be secured. But that's not the case. You're still going to have a lot of problems that are existing in a non-container environment. But the traditional environment, security tools can't understand containers. Containers are not based off IP addresses. They have namespace, they have projects, they spin up and spin down instantaneously in some cases. So if you try to use Qualys or one of the other Tenable or other security tools on containers, they don't work. And those other companies are making container-specific tools now, where they realize that their solution doesn't work. So there's a lot of risks that come in containers. So you're not immune to it. And I'm going to show you a couple of demonstrations of actual. Can you ask questions now? Or? Yeah, you can ask whenever.
Are you gonna talk about why Qualys does not work for containers?
Why what?
Why Qualys,
Qualys.
yeah, it does not work for containers.
Yeah, sure. Qualys, again, it's traditional scanning. Qualys does have a product now that's targeting containers, but they're really far behind. And that just came out a few months ago. So before that, everyone had the Qualys scanners. They don't work because they don't understand containers. Containers are different, right? So you don't have an IP address, hey, hit this hole, this is the IP address, go scan this. It's very different when you think about containers. And a lot of other solutions, they look at scanning. When you typically look at VM images, traditional environments, you scan them. You scan for viruses, you scan for vulnerability, you scan for something. You're scanning the actual host, your actual application. The way it should be done on container-related technologies is you scan the image. Because a container is based off the image. An image, when you're building it, it's not running, it's still not image, it's just a package. And you scan that. Once you scan that and you instantiate it as a container, you know the container is good because that container, the image that it's based off is good. So if the source is good, you're going to be good. But there's also ongoing scanning that needs to be done. But again, you never hit a running container. You don't want to add overhead to a running container. Containers are small, they're lightweight, they're meant to be very fast, do what they do. When you start adding layers of security on top of it or other tools on top of it, it really defeats the purpose of what a container should do. It becomes slower or bogged down, and resources attached to a container are very limited. I'll show you a couple of examples of actual hacks and scanning that goes on. But yeah, if anyone has a question, please go ahead, stop me. So before containers, you started your coding, your static analysis, compile package, and at the same time, someone would provision a server, configure software, do the assessment, and those two things will merge. And I'm sure most of you are developers, and when you realize, hey, the code that I developed is not running on this environment, why? Or I don't have the latest JDK, or I don't have the Perl libraries, or something's missing, or something's different. So then you have problems that way. Then you have to go back and fix that either on the server side or on your side and merge those two and make it work. Now with containers, you don't have that anymore. You don't have this bottom layer because everything is within a container. All the libraries, all the files that you require are within the containers, within the image. So as you go along, you realize that on this side you deploy and that's it. Over here, when you deploy, you do more assessment, you go back, fix it, and deploy it. You already deployed. With containers, you don't do that. Once you deploy, you deploy. If there's a problem, if there's a change that you need to do, you need to come back to the beginning and fix it, and go through your CI/CD process, test it, scan it, whatever you need to do, and then go on and build. And it's really easy to do that. To pull down a container and upload a new container, or start running a container. So the whole thinking has to change. What could happen, right? So, what could happen in your environment about when you're running containers? You can have unauthorized images. Unauthorized images are any image that your corporate or your security team didn't approve. You could go to Docker Hub and pull down an image. Docker pull whatever you want, and it pulls down an image and runs it. And you didn't want that to happen, right? So you need to be able to protect against that. A lot of development happens around open source libraries and open source packages. So you have to be able to scan those packages, those libraries, those scripts, whatever you're using, and be able to say, hey, these are clean, there's no vulnerabilities in them, and then I could go ahead and develop with that. Insecure configuration, remember that one. I'll show you what major companies got hacked because of insecure configuration. Privilege escalations, when you get your, when someone in a container could come out of a container, get escalated privileges and do more damage to the environment. There's also networking attack, and there's, anyone could do anything when you have an unsecure container environment. There we go. These are an example of public breaches. Does anyone know what happened with Tesla? Jenkins? Docker? Tesla had a misconfiguration. They left their Kubernetes environment open on AWS. Hackers were able to get in and deploy crypto mining tools. I hope they made enough money to buy themselves a Tesla. Jenkins, same thing, misconfiguration. They left their environment open and hackers got in, deployed crypto mining tool. They definitely made enough money to buy Teslas. Now hopefully they can get delivered. And Docker Hub. This is, I think, the latest. Back in June at DockerCon, Docker discovered 17 images that had backdoors in it. Docker scanned these images on the environment, so it's been security scanned, but they didn't pick up any of the backdoor images, the backdoor access. So what happened then, again, hackers, once someone ran that image as a container, they got in and they deployed crypto mining tools on it to mine for coins and really screw them up. Or wherever that individual people were using those images. Again, coming from Docker Hub, it was scanned and you had those problems. And then you have the Apache Struts issue, which was very big recently, along with Heartbleed, Experian, all these other big companies that were affected by the Struts vulnerability. So this is where we come in. I won't go over this marketing slide. So how do you protect against that? So what you should do, the best practice really is to integrate early on as you build a build cycle, like through your Jenkins, GitLab, or VSTS, whatever your CI/CD tool is that you use to build. You should integrate security early on, and have the scanning done right after the build is done. You should either fail the build if it has vulnerabilities, or if it fails your security policy, and then it should go to the next level and to the orchestrator and to deploy it at runtime. Another thing that you should be concerned about and think about is if you do scan, like with crawlers or with other tools that just do scanning, that they're started with containers, you want to make sure that the image that you scan and approve is the image that you run at runtime. There shouldn't be, technically, once it goes out of the build and goes to your registry, a developer go in there and say, oh, you know what? I wanted to add something new, but I don't want to go back to the beginning. I can go ahead and edit that image and upload a new image straight to the registry, bypass your build cycle, bypass the scanning. So you don't want that to happen. You don't want your developers to go in there and fix something and run it without scanning. You should be able to control it. You should be able to verify that the image that you scan is the image that you run at runtime. So this is how we do it. We actually integrate into the CI/CD tool. We quickly, we integrate with the CI/CD anything that's out there, and a lot of other people do this as well. And what's good about it here is you can fail it. You get early on notification. I used to be a developer at IBM for like 13 years, many years ago. And when I developed something, and my Jenkins came out as good, successfully built, I'll go on to the next step. Then operational security will come to me and tell me, hey, this thing that you're working on has a vulnerability. Could you go back and fix it? Now, many people who are developers, you know that once you finish with something and you're working on something else, you change your mindset. You're working on that project, you're fully developing that process or that project, and now you have to stop, go back and think about what you were doing before, and apply that fix or make a workaround for that. So ideally, what you want is to fail in the build process. Send that information to the developer saying that your build failed because of these vulnerabilities. Please go back and fix this. So what you're doing here is really the whole shift left movement. You're bringing the security tools to the developers. So by saying that, like the example I was giving you before about anyone could run anything, you need a gate there. You need a gate to allow what applications are allowed and what's not. Typically what happens is you have all the images in the world, like from Dr. Hub or from anywhere you want. Usually what happens is companies or organizations, enterprises, they have a trusted registry, a private registry, where they bring down only the images that they want to use. We go a little bit further than that. It's basically, you only allowed to run any images that have been registered and scanned by a solution like ours, and only allow those images to run. With that being in place, what happens is, if someone tries to go back to Dr. Hub and pull the image and run it, they'll be able to pull it, but they won't be able to run it, because a security tool like Aqua will be blocking it from running. We'll say that, hey, this image is not valid, it hasn't been scanned, so please go back and scan it. Any questions? Yeah.
Are you suggesting to pull a specific version of the image from the router?
What was that?
Are you suggesting to pull a specific version of the tag from the router image from the router?
Well, it doesn't matter what image. I'm not suggesting anything about that. What I'm saying is, you can pull any images you want, go through the security scanner, make sure that image is good. Just because it's an official image on Docker Hub, like for example, CentOS, it doesn't mean that it's clean. It doesn't have any vulnerability. You have to make sure all the vulnerabilities are addressed. Those vulnerabilities might not be important to you. I'm behind a firewall, or I'm an air gap environment, and I really don't need, this doesn't really affect me. So you have to make that decision. You have to build a policy to tell it, to make sure that the images that you are going to run are clean and valid.
How do you do with the latest?
How do you do that?
Latest tag. If you use the latest tag,
Yeah.
and you're going to be
Yeah, so if you use the latest tag, it's fine, because all those images are based off a hash. There's a hash associated with it. If tomorrow a new latest comes out, the hash will be different. So it really goes off by the hashes of the images. Yes?
So how do you actually say that that particular hash has been actually curated or scanned? Right? What is the Aqua security or any software that does scanning? How do you see that trust, or how do you say that?
Okay, how do you trust it that
Yes,
it's
trust that hash.
Yeah, so every application, every open source application, they have a hash associated with it. So could you spoof a hash? I'm sure you can, but that hash has to match what's inside the container. So we don't just look at a hash, or no one really looks at a hash and say, hey, this is the hash of that, I'm going to trust it. I'm going to calculate my hash on my own, and I'm going to match it with what they say it is. If there's a difference, then there's a problem.
Right. But how do you know that hash has been actually, that particular image with that hash has been scanned?
Okay.
So is there some sort of container store or something?
Yeah.
Within Aqua that stores all the scan?
Yeah, I'll show you that, right? So once you scan the image, we keep that in our backend database, locally to your environment, and then it refers to that every time. So if there's a new image latest, and you try to pull that new latest image, the hashes will be different. It's gonna check the store in the backend and say, hey, is this the same? No, let me scan it again then. So there is a backend registry in the system. Cool. So you should be, like I mentioned, you should be able to block unauthorized images if the image you haven't scanned, and if I scan in CentOS latest, someone brings in CentOS 7 or 6 and tries to run it, it hasn't been scanned, so you want to be able to block it. So that should be a possibility. What I'll do is let me jump to the actual demo of a couple of solutions so that you can see it happening. I don't like going over slides, it's pretty boring. But if you want, I have 50 more. We could go over. Yeah? Cool. Did you guys see this? Okay, so this is just, now I'm going to the actual product of what we have. This is what I have access to. This is what I could show you and run and actually show you how do you protect yourself against attacks. So what happened with Tesla, Jenkins, and Docker, and your question that you had. So what I typically show is, this is the dashboard. More importantly, it's the images section. So this is a list of images that we scanned already from either from our integration with CI/CD or from our integration with a registry. So this is the images that we scanned already. I don't have copy of these images on my machine. Once I scan it, I remove those images. So if you try to run an image that has been scanned already and approved, it will run. You're not going to get anything from here. You're going to get it from your registry, from your Artifactory registry, Docker Hub registry, your private registry, GCR, ECR, whatever it might be. So I scanned a bunch of images already, and let me just quickly show you this. Here's my Jenkins environment. I already integrated with Aqua. Okay, so this image is ordered Nginx. It's based on the Alpine 3.7 image, and this is the actual scanning part. So when an image actually runs, we scan. This is how you scan it. You pass this command as a step in your build to push that Alpine 3.7 image to our scanner. So this shifts the image to there, scans the image. So this is what it does when it scans the image. It inspects the image, it gets the history, and analyzes the image, and calculates the digest. So what's happening here, I'm sure others do this too. They rip apart the image, they catalog each and every component and the whole image, and get the hash of each of the components. Once it determines the hash of all the components, it contacts our cyber center. It's a security vulnerability database that's typically in the cloud, and asks, hey, do I have any vulnerabilities in this and these hashes? Yes, where are they? And then it goes ahead and applies it. But this image, the Alpine 3.7 image, is a clean image, there's no problem. So it goes ahead and adds all the other layers to it. And then we come back to the bottom, the last step. So this is a step that I normally would have seen before, successfully built. It means that your application is good, everything connected, it worked, you're good to go. This is where you typically stop, and you ship this off to your registry, and your job is done. But here we run another scan here. Yes, question?
So is the entire content of the image sent to your server for scanning?
Yeah, so I didn't give you an overview of the architect, but what happens is everything's on your local environment, nothing's on Aqua. So, well, that cloud environment is just a vulnerability database, just a list of all the vulnerabilities. It's like a your virus scanners. You get the virus definition, something similar to that.
So it should install
So everything should be on your local prem, on your own container environment. The vulnerability database lives in the cloud, but you can bring that on-prem as well.
So the question is, should we be talking to your my regular build?
Yeah.
Should I be connecting?
Yeah, if you want to have that, the scanning part, right?
Second thing is, you slice the Docker layer better, or just you split the Docker to go forward?
What was the question, sorry?
The Docker layer better, right?
Yeah.
So you slice as a Docker layer, or you just expand the image and go to the folder structure and do whatever?
Yeah, so there's options there, depending on how you want to scan it. So you can actually have a scan on each of the layers, or if you wait till the end to do a scan on the whole completed image. And in this case, we did one after the base image, and then at the end, just to show you what it looks like.
So you said configuration based validation, right? So do you check for any, if I have container Kubernetes build or some configuration for my platform, do you check against that also?
Yeah, so that's not over here, but yes, we do check for that, and that's called our CIS benchmark against Kubernetes or Docker environments. Good question, and I was going to get to that later how that works.
Can you summarize the question as well?
Yeah, so couple of questions he asked is, we have a vulnerability database that lives in the cloud. So do we ship the images to the cloud to get scanned and come back to it? And the answer is no. The vulnerability database is just a list of vulnerabilities. And it's just a list of vulnerabilities. It's like a virus definition. And the second question is, do we scan layer by layer of a Docker image or the whole thing? So it's really up to you. You can have a scan on each of the layers and scan the layers, or you can do it at the end. And typically people do it at the end. And the third question was about the configuration. Do we check the configuration of your Kubernetes environment? Yes, we do, and there's a way, we don't do it here, but there's another way we do it. And in fact, if we have time, I'm sure we'll have time. I'll end it early if you don't. But I want to show you an open source tool that we have. It's free, it's open source, it's called Kube Hunter. It's a penetration testing tool for Kubernetes environment. So I'll show you how that works. It's totally free, and you guys can just use it. So back here, technically we stop here. I'm good, I go on vacation, my build is successful. But now we do another Aqua scan here. This is one, same Docker run command, and this time it fails. So so the developer will get a notification that your build failed. He or she will go back and get the results, get a nice HTML page showing you that it failed, what the issues were. Let me see if I can show you that quickly here. So then you'll get to see something like this. The image is disallowed. It has one high vulnerability, 2 medium one, and my policy failed this one because it contained a blacklisted CVE. So the policy that we built within Aqua says that if any image contains this CVE, I want you to fail it. That's what I'm looking for. I'm not looking for high, medium, low right now. I'm just looking to see if it has that CVE. So that's why it failed. If I go to the vulnerabilities tab, this is from a developer's perspective. So the idea about here is give the developer as much information as possible for them to go fix their problems. You don't have to wait weeks or months for operations security to tell them you have a problem. So you really want to get these tools to the developer. And then get this nice report showing that, hey, this is the high one, this is a CVE that's causing a problem, so go fix it. We give a link to the vendor's page about that problem, and they could read about it and go fix it. Or if there's no fix available for it, they could, at least they know what the problem is, and they can start thinking about how to go about fixing it. Cool. And I know, let me show you this one too, I guess. Command prompt is always fun. So what you can also do is do an ad hoc scan. An ad hoc scan is just a scan on your local environment as a developer and scan for vulnerabilities. What's good about it here is I know companies like Sumo Logic, for example. I was on a talk with them one day and he gave this example. They reward the developers that have the least vulnerabilities. And they make the developer who has a problem, talk about it. Anyone here from Sumo Logic? Good, then I can make up stuff. No, but seriously. So what happens is, if you have a problem, if you have a vulnerability, they'll make you do a lunch and learn. What was the problem? Talk about it. How do you go around it? Stuff like that. Nothing bad. But what this allows you to do is scan your images before you push it to your CI/CD, which is good because if you fix your problem before you put it in, your manager would think that, hey, you write great code. And what's interesting here, I put the output in JSON format, so it's easier to read than HTML. But if you wanted to read HTML, you could just use that HTML flag and read HTML on the terminal. But yeah, so this gives you a good result. It's all API based, so you can actually pull this in. Okay, cool. Let's go back here. I'm showing the product just so you get an understanding of what it is, but I really want to show you the other parts of it that actually helps you protect the running container. So the image that we scanned in through our Jenkins site was this order Nginx. You can see it has this disallowed. This disallowed means that it failed the check, and Aqua is not going to allow this image to run on your container. So this is a good way to enforce a rule that says only approved images are allowed to run. If I try to go to my terminal command prompt and do a Docker run on that image, it's not going to work. It's going to be failure. Aqua is going to say, hey, it's not allowed. Now if I look at this other application, Orders Apache, it has 169 vulnerability, but the tag disallowed is not on it. That's because we didn't build any policy to tell it what to do. So we just open that up. Okay. These are all the checks that we've done. There's a lot more checks that you could add. The CVE was been blacklisted. If you go to the vulnerabilities tab, show more. So you can see from the base image that we scanned, there was no vulnerability, but when we added the other layers on top of it, there were vulnerabilities. To your question, if you did more scans in between, they will show you layer by layer where the vulnerability came from. But in effect, you just want to see the full image and get the result. Here you have the results here, high, medium, low. And now you get a good description, solution, and a fixed version of what the problem is, how to go about fixing it. Now this is an Aqua plugin now. You notice how we gave you 2 scores? What's unique about the way we do it, other than the way the other people do it, is we subscribe to many different sources, not just the public NVD database. Public NVD database is good. It's a government agency, NIST, and it has this database, but they get it from different sources and then put it together. It takes a little while for that to happen. So when you, like, for example, when you had the OpenSSL vulnerability, the Heartbleed issue, when that patch came out, a lot of vendors, they backported that fix to earlier release. And with Aqua, just because it subscribes to many different sources of vulnerability lists, we would be able to pick that up, say that you applied your fix. But the NVD's database took about a month or more for it to get updated with all the fixes. So you had false positive in your environment. But with a solution like Aqua, we eliminate a lot of false positives. So let's quickly go back here. I'm not going to spend much time here, but I just wanted to show you what it looks like. So this is the CVE that we added, 2016-2515. We were blacklisting it, so you have to manually add it. But here are the other controls that's available to you. Say that you don't want to do it manually. You just wanted to block everything that's high, medium, low. You could. Just take this one and select, medium, high, low, and click on save. Now all the images that had high vulnerabilities, they got disallowed. CentOS, for example, it's 6.8, and the latest, they're all disallowed because they do have high vulnerabilities. Just because I got CentOS from the Docker Hub image, the official Docker Hub page for them, they still had vulnerability. It doesn't mean it's clean. Just because they get it from our official registry, don't expect it to be clean and good to go. You need to do scanning. If you don't use Aqua, that's fine. There are a lot of great solutions out there. There's any of the cloud providers, Google, a lot of the registries, the Artifactories, for example, GitLab, they have their own scanning. And their own scanning is based off of Clear. Clear is an open source scanning tool, which is better than nothing. So if you're gonna do scanning, do something. It'll catch a lot of stuff, it won't catch everything, but it's definitely better than not doing anything. So you notice how I changed the policy and it quickly disallow anything. Disallow anything that's high vulnerability. It doesn't need to scan it over and over again. We scan the image once, and as long as that image has not changed, there's no need to scan the whole image. This information is in our database, what each of the components are. So when you scan an image, when you rescan something, it hits the database instead of hitting the actual image and rescanning the image or scanning a running container. If anything changes, the hashes will be different, then it will do a full scan. Cool. Now, hopefully this gives you an idea of how something like this would work. And I want to go in now and show you what would happen, like a real one-time issue. But before we do that, to your question, how do you check out the configuration? Tesla had a configuration problem, Jenkins had a configuration problem, so how do you protect against that? We have something called CIS benchmarks. So this will run automatically on your host environment and check your configuration, how it is. This is just my plain Docker environment, so I don't have anything on Kubernetes, but it tells you, gives you the alerts here. What are the problems? Host configuration, one high failure. So you get this information here. If Tesla or Docker or Jenkins or those were to use this, they would quickly realize that their thing is open and it shouldn't be open. So I can go, cut that off and you'll be okay. Or you'll be in better condition. But what I'm going to show you now is something pretty cool. It's called runtime protection. So now your image is scanned, you're clean, you're approved, you're good to go, you make it as a container, it's running as a container. How do you protect against that? You don't scan a running container over and over again. Like I said before, it's really intensive, it's high usage. You don't want to burden your container to extra stuff that it doesn't need it. Containers could spin up and spin down. Before your scanning even completes, your container could come down. So there's a whole theory behind that and logic behind it why you don't scan running containers like other solutions like Qualys and they try to do and then realize that that's not the best way to do it. So let's talk about runtime policy. There's a couple ways to do runtime policy. Here's one. You can base this off of NIST, CIS, HIPAA, or PCI compliant recommendation. Right now I have executable blacklist where I'm going to blacklist VinPS. So anywhere on my containers, any containers running on my host, if I exec into it and I'll try to do PS, it's going to block it. And the next thing is drift prevention. This is only for Linux right now. It's basically saying prevent any executable not in the original image from running. So what happened to Tesla and Jenkins and Docker, if they ignore the CIS benchmark telling them that their thing is open, if all they did was just have one check and that checkbox marked, they would have been fine. They wouldn't have that problem. A hacker could have got in and they wouldn't be able to deploy anything because that's going to prevent it from running. So I wanted to quickly show you a demo of that. Again, it's a live demo, so bear with me. Let's make it a little bit bigger. Okay, cool. So I'm going to exec into my WordPress container. Okay, I'm there. So I could do ls, do clear, who am I? And it works. I'm root. Now if I do ps, I get permission denied. I'm root on this host, on this container, and I'm doing ps. I'm still getting permission denied. I'm getting permission denied because in my policy that I set up, I'm blacklisting the executable. You can add more executable here to blacklist it, but we'll get there. We'll get to that in a minute. So it's pretty powerful, and everything here is audited, is logged. You can see if I look at my block events, would perform bin PS. It's been blocked. Captures all the information, so it's all logged. Now let me show you drift prevention. That's working fine. So ping is in my CV bin directory. Here's ping. So what I'm going to do now is I'm going to copy ping to Palm. You can see I have Palm here now. The permissions are the same. Everything is the same. The file size are the same. Okay, let's go ahead and do Palm local host. I get permission denied. Why I'm getting permission denied here is, even though ping was an allowed executable, Palm was not. Palm was not in the original image when we scanned it. So we're going to block that from happening. So if you put this, yes?
What happens if we name PS to ping?
Okay, let's try that. Well, the answer is it's not going to work, but I'll show you. Let's mv ping to ping-org. cpps to ping. So I copied it over there. You can see this file size is the same. Ping. I'll just type in ping because PS doesn't have that. I get permission denied. The reason why it's getting denied, to your question, which is good, is that we take the hash of it, we take the file size. There's a whole lot of information that we take from the original image. So if you change one thing, it will break the logic of it, and it won't allow it to run. Any other tests?
Question.
Go ahead.
So what do you have running on the machine to do this? Right
So the machine, let me show you. Actually, let me just move back ping original to there. Ping. So what happens is, I'll show you what's running on the machine. It's basically another container that we call the enforcer that gets deployed on your environment, on each host. Each host will have one sidecar container called the enforcer, and that really controls what's happening. Without giving you away and preempting any questions you might have around there, I can't give you away our secret sauce. So, but the way it works is, it works with a Docker socket. So, we're able to, see what's going on in the container, protect all the containers that are running, and control what happens there. I'm assuming you guys are familiar with the command line and everything, right? So let's go ahead and look at top. Top gives you all the processes running on the computer, on this container. It's pretty clean, nothing going on here. What I want to show you now, this is a live exploit. This is the exploit that would find, well, let me just run it. So it's going to find our WordPress environment, a container, and break into it, because we know how secure WordPress is, right? Really secure. And it's going to deploy a crypto mining tool to it. And then you can see it says permission denied. It's gotten into the environment. The miner has landed, but it can't run it. So put yourself in that test fuzzy environment in this situation. Someone broke in, try to deploy a crypto mining tool, it's not gonna run. It's being blocked. Now let's do an enforce off. Rerun this. So I turn off my enforcement, and I'm gonna rerun this. In a second or two, you should see that it executed. So let's go back into my environment. Let's do top again. And you can see, someone's making money off of me doing this demo. So the crypto mining tool is running, and it's deployed on the environment, it's running fine.
Could you show what is the name of that project essentially?
Sure. You want a copy? I can give you a copy of it. Let me just turn the enforcement back on. And let's just. And here's the exploit here. It's really going to that thing to log, finding where it is, and getting that information. You can see that.
Could talk out to some remote site.
Yeah. Yeah, exactly. I can give this here later on so you can take a look at it. Okay, cool.
And
So-
really quick, could you show what's an enforcement essentially?
What was that?
What's the enforcement?
Okay. It's just time to turn it on, turn it off. Oh, I'll reinforce. Cool. Okay, so what okay. So in this environment, I have this one here. This is the enforcer that's actually controlling it. It's actually our old name. This is the older demo, but this is what runs on the environment that's protecting all the containers on that particular host. So any of these hosts that I get into, if I try to do PS, it's not gonna work. I had another demo of a dirty cow. Are you guys familiar with the dirty cow exploit? So what happens is I'm in a container, and if I run the container and I mount, like say, Etsy password file, I can mount that onto my container, and even though if it's read only, I could still using the dirty cow exploit, which was a 0-day exploit that just got a few years ago got open, but it was out there for like 11, 12 years. What that exploit would do is it would create a user. It would break in and create a user and give me root access to the underlying system. So for my container, break out and go in. So basically it creates a user and a password, and you can do whatever you want to do it. And I just didn't have enough time to finish up that demo to show you. But there's a way you can protect that from happening. And one way is this what I just showed you is blocking unknown executables from running. So that's one way to do it. Cool? Any questions? We got about, what, 8 minutes remaining? Okay. I'll show you one more thing here, and then I want to quickly jump over to the Cube Hunter, and we'll do a live. Yeah?
Is there a tool on AWS to look up ECR interfacing and things?
Actually, on AWS, you can use our scanner on AWS. They have our scanner there to do it as a paper scan.
Oh, okay.
But we also have a free version called the micro scanner that anyone can use. Again, it's open source, but it's not as comprehensive as the official scanner. If you're on GCR on Google Cloud Environment, GCP, you can actually deploy Aqua onto your environment and do consumption pricing, and it takes like maybe 2 minutes to push a button and let Google do everything for you. That's coming to Amazon and Azure too soon.
What's the overhead of this?
Good question. So overhead, we don't like giving out overheads because every environment is different. So you might have, it all depends on how big your images are, how good your network is, how heavy and powerful your machines are. So it all depends. Customers that I have dealt with, big financial insurance company, they've done testing on their own environment using Datadog, Prometheus, New Relic monitoring, and they came back and said that overhead increase that they saw was 0.8 to 1.2%. But it was too little for them to really worry about it. So it's not heavy at all. I didn't show you the architecture slide on purpose, but we can always talk more about it, how it's architected. It's very scalable. it offloads a lot of the heavy work to backend servers and whatnot. One thing I want to show you quickly here, and then I'll quickly jump into the Cube Hunter. So I showed you how to protect every single host on your environment. Question? Okay, stretching. Yeah.
So what you showed earlier, where it checks for vulnerabilities along it breaks up each image into its layers, checks the vulnerabilities, right? If you put like all the thing in one command, would that hide those vulnerabilities?
No, it doesn't break up the layer. It just breaks up the whole image and sees what are the components that are used to build that image,
Okay.
regardless of the layers.
Okay.
Cool. So I just showed you a quick one-time protection on everything. But what I could do is, like this MySQL, I could build a profile. It's called an image profile to say that, hey, MySQL should only do this. Because remember, the whole idea of container was the whole microservice. It should do only the thing it's supposed to do. So if this is a MySQL image, it should only do MySQL work. But many people, when they develop containers, they build it on heavy backend operating system like Ubuntu or Debian, the whole image. So you get everything there. So you want to be able to harden and isolate that. There's a couple ways we could do it. You could use our profile that exists already, create a new one, or have Aqua watch it and then create the profile for you. That's what I want to quickly show you here. So what happens is we're going to pass this environment variable -e Aqua profile. When our enforcer that's on your container sees that, it means that I'm going to watch this container and see what's happening. You can see that there's a little record icon here. So if I click on it, in the last 10 seconds of this application running, I capture these are the executables that are being used right now. I'm just marking fake traffic going in, so it executes something. This is the min-max average CPU memory in the last 30, 40 seconds. The network calls, the system call, environment variable, and the user count. So this is telling me that only JBoss could connect to it. Let's just kill it. So it takes this profile. This is how a profile looks like. You won't see this. I just wrote a script to do all that heavy work for me. Let's just go back here. You can have Aqua watch your application over a period of time, like 10 minutes, okay, an hour, whatever, or 2 days. So I created this profile, and these are the only executables are allowed. So if I go back into my environment where that's running, I get permission denied. I'm getting permission denied because root does not have access to it. Now I'm in there. You can see I get permission denied on other stuff because these executables were not listed. If I'm a hacker, first thing I'm going to do is do ls. Oh, no ls. Via hack me. Oh, nothing there. Curl something. Nope. So all that's not working because we don't have that in our profile here. So if I add user bin ls, add, go down, save it. I didn't kill my container, I didn't restart my container, but container is still there. You can see ls works. So that's, and all that's captured to your audit. It gets sent to your SIEM or analytics tool like Splunk, AWS CloudWatch, whatever you might be. We have about a minute remaining. So I just want to quickly show you Cube Hunter. So if you Google Cube Hunter.aqua.com. Here's our page. So this is our Cube Hunter. You can go to GitLab page if you want to give us your email address, but put in the email address, you get this command here. You know what? Actually, you know, I did this already, so I should have the URL. You get that command, you run it on your container environment, and it basically scans either your local environment or external environment. Oh, you know what? Go back a little bit. You didn't hear anything yet. This is for education purpose only. Don't do this for any harm. So you could scan anything you want. So when you run that command, I'll show you how the command looks like. Let's exit out of it. Punch. Sorry, I'll be done in a minute. So what it's going to do is it's going to download Kubuntu locally and run it. While it runs, I'll show you what the output is. So this is what my vulnerability scanning looks like. It scanned my Kubernetes environment. I have a 2-node environment, and it found all these vulnerabilities, what hackers could get access to. The market by severity. It's open source, so it's always being updated. People are always adding value to it. So you can just go ahead and download this and run it. This is what it looks like when it runs. Remote scanning, subnet scanning, or IP range. I did number 2. I scanned my local environment. But you can scan anything that you want. Now I scanned against my Google environment, Google Cloud Kubernetes environment. It was pretty clean. But anyway, that's that. I'm out of time. I'm here for answering any other questions later. Thank you.
Thank you, Kashif. Thanks a lot.
Well, I have pens and other goodies over there if you guys have.